Good morning. Welcome to the February 26th, 27th ACIP 2020 ACIP meeting. I will now turn it over to Dr. Cohn.
Good morning, everyone, and welcome. Slides will be presented at this meeting will be posted on the ACIP website approximately 4 weeks after the meeting. The live webcast videos will be posted in approximately 4 weeks as well. Oh, sorry, I skipped the first slide. Okay. So the proceedings of this meeting are accessible to people not in attendance via the World Wide Web. Welcome to those who cannot attend this meeting in person. There are CDC staff at the entrance of the rooms to help guide you, and there's also a desk in the lobby to assist members of the public with questions. Handouts of the slides to be presented have been distributed to the ACIP members and are available for members of the public on the table outside this auditorium. Additionally, slides are available through a share file link for liaison and ex officio members. Next slide, thanks. Slides presented at this meeting will be posted on the ACIP website approximately 4 weeks after the meeting. The live webcast videos will be posted in approximately 4 weeks as well. Meeting minutes are posted on the ACIP website generally within 120 days of the meeting. Minutes from the October meeting will be posted on the ACIP website shortly. I'm going to go over next slide, please. Thanks. I'm going to go over a couple of pieces of information to make sure all of you are safe. To ensure the safety and health of the individuals attending the meeting, a few safety regulations must be reviewed. In the event of an emergency resulting in evacuation, the procedures are as follows. The back of the room should exit out the rear of the door and across the bridge the way you came in. The front of the room should exit through these doors up here, turn left, and then right down the stairs. Locate the blue building marker sign labeled Conference and Meeting Space, second floor, GCC, and group together to ensure all attendees are accounted for. Once the premises have been secured and all clear has been issued, you may re-enter the building and resume our scheduled meeting. Hopefully that will not happen. Next slide. This is just a visual so you can see where you should go in case of an emergency. Next slide. At this meeting, coffee and breakfast items are being served in the lobby, followed by Chick-fil-A and a Thai option at this meeting during the lunch hour. These services will be available both days, both of the meeting days. If you do leave the building during lunch, as you saw this morning, please anticipate large security lines to get back in. So we highly recommend you use the food items. You can also go downstairs to the cafeteria as well. Next slide. The next ACIP meeting will be convened at CDC on Wednesday and Thursday, June 24th and June 25th, 2020. Registration for all meeting attendees is required and will open on the ACIP website when the Federal Register notice is published. Registration is not required for webcast viewing. Next slide. We have one new liaison organization that is joining ACIP that I want to welcome. It's the International Society for Travel Medicine. Dr. Elizabeth Barnett, who's a professor of pediatrics at Boston University, is sitting back there, will be the organization's liaison representative. Welcome. Next slide. We have a couple of member substitutions for this meeting. We have 2 ex officio representatives here. Dr. Kara Alam is here with OIDP, although she's not here yet. And Dr. Barbara Mullock is here representing NIH. So thank you for coming. I do want to mention that we just heard that we have 2 liaison representatives whose meetings will be the last one today. The first is Dr. David Weber, who has been representing us here for many, many years. I can't think of how many. Where are you, Dr. Weber? Yeah, where? I don't see him. He's usually sitting there. Oh, he's not here yet. Okay, that makes me feel better. So he's invisible right now, but he has been at our ACIP members representing SHE for many, many years, and we appreciate all of the support he has given ACIP over the years. Our second person whose meeting will be the last one today is Dr. Susan Eden, who's been representing the American College Health Association. I think ever since I can remember, which is a long time now. We also thank you for all of your support and leadership representing college organizations at ACIP over many, many years. So thank you guys. The next slide, we also have many guest attendees at this meeting, special guest attendees at this meeting. CDC was honored to host the Global NITAG Network meeting. ACIP is, NITAG stands for a National Immunization Technical Advisory Group, of which ACIP is the US NITAG. And so we had representatives from, I believe, is it something like 40 countries, Louise, that were represented? 60? 50-something countries were represented at a meeting at CDC over the last 2 days, talking about how to build NITAGs across the world to make immunization policy. We will have meetings attending, we will have those meeting attendees will be coming in and out and watching the meeting both in another space as well as in the room. We also have students from the Walker School who come each year to an ACIP meeting and are watching in a distant learning center here in a different room on the television. And I believe tomorrow we'll have students from the University of Alabama School of Public Health here. So welcome to all of you. I also just want to acknowledge Dr. Alejandro Craviado, who's here. He's sitting right over here he's the chair of SAGE, and Dr. John Abramson, who's a former ACIP chair, former SAGE chair, and they have been here for meetings with us around global immunization and are here representing SAGE today. So thank you guys for being here. Next slide. The Advisory Committee on Immunization Practices is at heart a public body. Engagement with the public and transparency in our processes is vital to the committee's work. As part of ACIP's commitment to continuous improvement, we've been strengthening the oral and written public comment process to accommodate increased public interest, maximize opportunities for public comment, and make public comment more transparent and efficient. So for this meeting, we will be holding one public comment period this afternoon. The oral public comment period will occur at approximately 1:15 p.m. after lunch. This will be prior to the one anticipated vote of the day on Ebola vaccines. To create a fair and efficient process for requesting an oral comment, people interested in making an oral comment are requested to submit a request online in advance of the meeting. Priority is given to these advanced requests. We have been conducting a lottery where people are randomly selected from all of the individuals who request to make an oral public comment. If you are here to make public comment at this meeting, please make sure you sign in at the information table outside the main auditorium so we know you're here. I also want to let everyone know that you can submit a written public comment via regulations.gov using the docket number ID CDC/2020/0002. Information on the written public comment process, including information about how to make a public comment, can be found on the ACIP website. Regulations.gov will close approximately, I believe, 24 hours after this meeting. So you are welcome to make a public comment both before the meeting and during the meeting as well. Next slide. As noted in our ACIP Public Policies and Procedures Manual, members of the ACIP agree to forego participation in certain activities related to vaccines during their tenure on the committee. For certain other interests that potentially enhance a member's expertise while serving on the committee, CDC has issued limited conflicts of interest waivers. Members who conduct vaccine clinical trials or serve on data safety monitoring boards may present to the committee on matters related to those vaccines, but those members are prohibited from participating in committee votes related to those vaccines. Regarding other vaccines of the concerned company, a member may participate in discussions, but must abstain from all votes related to the vaccines of that company. At the beginning of the meeting, when the ACIP members, when we do roll call, they'll acknowledge any potential conflicts of interest. And I also want to remind everyone that we will do that again at the time of the vote. Next slide. Detailed instructions for submission of names of potential candidates to serve as ACIP members are now available on the ACIP website. Applications for ACIP membership are due no later than July 1st, 2020, for the 4-year term beginning July 1st, 2021. So please encourage those you know to submit nominations for ACIP membership. We always appreciate the outstanding, both the number of applicants and the level of expertise in the applicant pool is really extraordinary. So thank you all. So before I hand it over to Dr. Romero for roll call, I just want to remind everyone to please turn off your cell phones to avoid disruption. Thank you.
Okay, so I'll now begin to take roll call. Would the current members please introduce themselves, indicate if present, and then disclose any conflicts? And I'll begin. Jose Romero, no conflicts.
Grace Lee, no conflicts.
Pablo Sanchez, no conflicts.
Kevin Alt, no conflicts.
Lynn Bata, no conflicts.
Kip Talbot, no conflicts.
Robert Atmar, no conflicts.
Peter Szilagyi, no conflicts.
Hank Bernstein, no conflicts.
Kathy Paling, no conflicts.
Veronica McNally, no conflicts.
Paul Hunter, no conflicts.
Beth Bell, no conflicts. Sharon Fry, no conflicts.
Thank you all. So next we'll proceed to starting with Dr. Melinda Wharton.
Nancy's here now.
Oh, Nancy, sorry. Sorry, Nancy. Starting with Dr. Massinier, then Dr. Wharton, and then ex officio members and liaison members, please introduce yourselves and the agency organizations you represent.
Nancy Messonnier, CDC. As you can imagine, I expect to be called away and not be able to participate in the whole meeting, so Dr. Wharton has graciously agreed to sit in.
Melinda Wharton, CDC.
Barbara Malak, National Institutes of Health.
Mary Rubin, HRSA.
Doran Fink, U.S. Food and Drug Administration.
Eric Dusing, Department of Defense.
Tom Weiser, Indian Health Service.
Jane Kim, Department of Veterans Affairs.
Amy Middleman, the Society for Adolescent Health and Medicine.
Sean O'Leary, Pediatric Infectious Diseases Society.
Pat Whitley-Williams, National Medical Association.
David Weber, Society for Healthcare Epidemiology of America.
Patsy Stinchfield, National Association of Pediatric Nurse Practitioners.
Corey Robertson, Pharmaceutical Research and Manufacturers of America.
Bill Schaffner, National Foundation for Infectious Diseases.
Elizabeth Barnett, International Society for Travel Medicine.
Jeff Duchin, Infectious Disease Society of America and National Association of City and County Health Officials.
Chris Ahn, Council of State and Territorial Epidemiologists.
Chris Finley, Association of Immunization Managers.
Steve Foster, American Pharmacists Association.
Chad Riddle, American Nurses Association.
Sandra Freihofer, American Medical Association.
Rebecca Coyle, American Immunization Registry Association.
Ken Spader, American Geriatric Society.
Jason Goldman, American College of Physicians.
Linda Eckert, American College of Obstetrics and Gynecology.
Carol Hayes, American College of Nurse Midwives.
Susan Even, American College Health Association.
Marie-Michelle Léger, American Academy of Physician Assistants.
David Kimberlin, American Academy of Pediatrics, Red Book.
Bonnie Maldonado, American Academy of Pediatrics, Committee on Infectious Diseases.
Pamela Rockwell, American Academy of Family Physicians.
Thank you all and welcome. So we'll proceed now to our agenda. First item is Ebola virus. We're going to have an introduction followed by a review of Ebola virus and the vaccine, then a question and answer period, then on to grade and ETR, followed by a question period, and then a summary prior to the break. So let's begin with introduction by Dr. Fry. Thank you.
As Dr. Fry is going up to the microphone, I do want to thank everybody for their patience with getting into the building this morning. I know it was an exceptionally long line, and thank you all. I know people will be trickling in. I'm guessing there's still a line outside.
Good morning. This morning I'm going to go through the activities of the Ebola Virus Vaccine Work Group since we have met during the past meeting in October. Okay. The ACIP members are listed here for you, Beth Bell and Robert Atmar. I'd like to thank them for all their hard work in the last few months. I'd like to also thank our ex officio members. I do want to point out that Mary Choi is our CDC lead, and she has done an enormous amount of work since you saw her last. I would like to thank our liaison representatives and consultants. Particularly our grade consultants who have been extremely helpful during the past few months, and all of our CDC contributors. We'll also hear later from Caitlin Casaboom. So this is a recap of the Ebola virus sessions since October. We did introduce the group last time. We also introduced our terms of reference. That was to review available data on the vaccine, the Ebola vaccine, which is a recombinant vesicular stomatitis virus with a substituted envelope glycoprotein of the Zaire Ebola virus. The particular strain is Kickwick 1995 strain. And to inform domestic vaccine policy options for the ACIP's consideration. We also worked on recommendations for the use of the vaccine in pre-exposure vaccination of healthy adults greater than 18 years of age in the United States at occupational risk for exposure to Ebola virus. Again, when I refer to Ebola virus, I will specifically be talking about species Zaire Ebola virus. Here are our key events since October. In November, the Ebola virus vaccine was granted EU-wide conditional marketing authorization. The vaccine is indicated for the immunization of individuals 18 years of age and older to protect against Ebola virus disease caused by Ebola virus Zaire Ebola virus species. In December, the U.S. FDA approved this vaccine for individuals 18 years of age or older for the prevention of Ebola virus disease. In February, the World Health Organization's Emergency Committee unanimously agreed that the ongoing EVD outbreak in Eastern Democratic Republic of Congo still constitutes a public health emergency of international concern. What are some of the activities and discussions that have occurred since October? We identify 3 U.S. populations at highest risk for potential occupational exposure to Ebola virus for whom potential policy options are most urgent. Those 3 groups are listed here for you and include individuals responding to an outbreak of Ebola virus disease, individuals who work as laboratorians and support staff at biosafety level 4 facilities that handle replication-competent Ebola virus, and healthcare personnel at a federally designated Ebola treatment center involved in care and transport of confirmed EVD patients with Ebola virus disease. I will go through later a definition of healthcare personnel, but please be advised that this is an extremely broad definition that includes many people of various job descriptions. Here are other discussions that we've had. We talked about additional U.S. populations with potential risk for occupational exposure, and these include the 3 listed here. These are healthcare personnel at state or jurisdictionally designated Ebola treatment centers, healthcare personnel at Ebola assessment hospitals, and healthcare personnel at the frontline facilities. We will be discussing these populations in more detail in the next few months, but I want you to know that we are discussing them, and the 3 populations we'll be talking about mostly today are the 3 that I previously listed. So further discussions occurred since October. We developed a protocol for systematic review of vaccine data and selected critical outcomes to be considered. We had a systematic review of vaccine literature for grade analysis and also for evidence to recommend, and have had multiple discussions on proposed policy options. Our agenda overview is given here for you. Dr. Mary Choi will have 3 of the talks, and Dr. Kasaboom will give the second talk. These are review of Ebola virus disease and the vaccine, grade for the data that we have, evidence for recommendations, and a summary of the working group considerations and proposed policy options. So this is the healthcare personnel definition that I want to bring to your attention. Please note that healthcare personnel refers to all paid and unpaid persons in healthcare settings. Also want to point out that this is an ACIP approved definition for healthcare personnel. So these are people who have potential for direct or indirect exposure to infectious materials, which are listed there for you and are many. These people include but are not limited to emergency medical service personnel, nursing and nursing associated positions, physicians, technicians, laboratory people, autopsy therapists, phlebotomists, and so forth, including contractual staff not employed by the healthcare facility or not directly involved in patient care, but who may be exposed to infectious agents that are transmitted in the healthcare setting. And you can see the ones that are listed there. It's quite extensive. And so I'd like to thank you. And the next person, Dr. Choi. Thanks.
Hello, my name is Mary Choi. I'm a medical epidemiologist with Viral Special Pathogens Branch. And in this session, I'll be reviewing a little bit of background material to set the stage for our subsequent sessions. So in this presentation, I'll be going over some basics about Ebola virus disease, as well as the vaccine, and then setting the stage and talking about the parameters for our workgroup discussions over the past several months. So Ebola virus disease in humans is a deadly disease caused by infection with one of 4 viruses within the genus Ebola virus, family Filoviridae. And those 4 viruses are listed here. For the remainder of this session and subsequent sessions, we're going to focus on one of these viruses, which is called Ebola virus, species Zaire Ebola virus. So this virus is responsible for the majority of reported EVD outbreaks, including the 2 largest in history, the 2014-2016 West Africa outbreak, which resulted in a little over 28,000 cases and 11,000 deaths, as well as the current Eastern Democratic Republic of Congo outbreak. In total, this virus has infected over 31,000 persons and resulted in 12,000 deaths. And untreated mortality rates can be as high as 70 to 90%. And currently, there is no FDA-approved treatment. The animal reservoir for Ebola virus is unknown. However, based on studies in similar viruses, we believe the reservoir to be fruit bats. So the slide here talks about a study that was done in the early 2000s by Leroy and colleagues, where they actually trapped bats, birds, and rodents in both Gabon and Democratic Republic of Congo, in and around areas where there were known Ebola outbreaks, either in humans and animals. And they were able to identify 3 species of bats. You can see the pictures here on the left, in which they were able to detect Ebola virus by both serology and by PCR. And the map on the left will show you kind of the geographic distributions of these species. It is important to note that none of these species exist in the United States. The signs and symptoms of Ebola are listed here and include fever, headache, fatigue, abdominal pain, nausea, vomiting, diarrhea. We can see bleeding in Ebola virus disease, but it's not universally present, maybe in about 40% of the cases. When we do see bleeding associated with Ebola, it usually is a late sign and pre-terminal. And as you could see, the signs and symptoms here are very nonspecific and really can be seen in many other diseases that are endemic in Africa. In infected persons, Ebola virus can be found in all body fluids, including the ones listed here. And person-to-person transmission occurs through contact, through broken skin, non-intact skin, or mucosal membranes with the body fluids of someone who's sick or has died of Ebola. In those who survive the acute illness, they often suffer some sequelae. Now, the true incidence of sequelae amongst Ebola survivors is really unknown primarily because oftentimes these outbreaks happen in countries where there's limited access to healthcare or specialized services. However, there have been some studies done, particularly following West Africa, and the most commonly reported symptoms are listed here and include arthralgia, myalgia, abdominal pain. The uveitis can be quite severe and lead to cataract formation and blindness. There was one study done following West Africa that found that within a year of discharge, Ebola survivors had a 5 times greater mortality than general population. When they looked into this further using verbal autopsy, it seems that a lot of these deaths were potentially related to renal disease that might have been precipitated by the acute infection. We also know that Ebola virus can persist in immune-privileged sites, such as the testes, the eye, the brain, and the placenta, and that in some instances, this has resulted in continued disease transmission and disease recrudescence. So I will give you an example. In Guinea, there was a man who was 15 months recovered from his illness, who then transmitted the virus sexually to partners. And this sparked a new cluster of disease that actually affected individuals both in Guinea and in Liberia. The instance of disease recrudescence that was been described in the literature was in a British nurse who was actually infected while working in Sierra Leone, fell ill while in the UK, was treated successfully. And about 9 months following her recovery, she returned to the hospital with meningoencephalitis picture, and they were able to detect Ebola virus in the CSF and then eventually the blood as well. So in August 1st, 2018, EVD outbreak was declared in Eastern Democratic Republic of Congo. When they sequenced the virus that was responsible for the outbreak, they found it to be Ebola virus, species Zaire Ebola virus. The current outbreak is the 10th outbreak in DRC, and it's the largest to have occurred there. And we'll see some slides showing some of this in a graph form. In July of 2019, the outbreak was declared a public health emergency of international concern because of cross-border travel-related cases that were detected in Uganda, as well as cases that were detected in Goma, which is a very large city in DRC. And the PHIC declaration was reaffirmed in February of 2020. So this is a graph of the case counts as of February 18th. Cases have been reported in 29 health zones and 3 provinces in Congo. And case counts are a little over 3,000 cases and a little over 2,000 deaths. Now, some people wonder, how does this current DRC outbreak compare to other outbreaks that have been in the area? So this is a graph of cumulative case counts for selected EVD outbreaks. As you can see in the legend, if the the red square, because this graph actually detects, is listing outbreaks not just from Zaire, but also from Sudan and Bundabujo. So I just wanted to delineate which of these lines correspond to which. So the red boxes means that it was a Sudan virus. The blue boxes mean it was Bundabujo. And if there's no box around it, then it's Zaire. And so basically what you can see is that the current DRC outbreak is by far the largest and lasting the longest. So this is a graph of the epi curve for the 2014-2016 West Africa outbreak, and then the current DRC outbreak in yellow. So Sierra Leone is in gray, Liberia is in orange, and Guinea is in blue. And as you can see, with the West Africa outbreak, particularly in Sierra Leone and Liberia, there was this period of time where there was a very, very rapid increase in number of cases where the curve almost goes in a straight line. And that the current outbreak in DRC has not, thankfully, followed that pattern and seems a little bit more gradual. So what about Ebola virus disease in the United States? So in total, there have been 11 individuals treated for EVD in the United States. All of them were associated with the 2014-2016 West Africa outbreak. 9 were infected in West Africa, and 2 died. There was one imported case of EVD that resulted in secondary transmission in the United States, and I think we all know that happened in Dallas, Texas. In addition to these 11 individuals, additional individuals have been repatriated to the United States following high-risk exposure to Ebola virus, but none of these people tested positive. And this repatriation happened both during the 2014-2016 outbreak as well as the current DRC outbreak. So as we all know, there is a vaccine. It's a live attenuated recombinant vesicular stomatitis virus vaccine. It's important to note that the vaccine cannot cause Ebola virus infection. The vaccine was initially developed by Public Health Canada and New Link Genetics, and currently Merck holds intellectual rights. The vaccine protects only against Ebola virus, species Zaire Ebola virus. And in December, FDA licensed the vaccine for individuals 18 years of age or older for the prevention of Ebola virus disease. So these are this slide here is courtesy of Merck. They presented this slide back at the October meeting, but I think it's important to kind of talk about how this vaccine was actually formed. So what happened was they took the vesicular stomatitis virus, which is on the right, and they removed the glycoprotein from that virus, which is the purple circles, spiky circles. And they removed that and they replaced it with the glycoprotein of the Zaire virus. And so the vaccine contains this recombinant virus, which is on the left. And once its person receives the vaccine, the virus will replicate, and then the person will develop antibodies towards the glycoprotein. The vaccine is administered IM. It's a one-time dose, and there are specific storage requirements for this vaccine. So it has to be held at -80 to -60 Celsius. Once it's thawed, it can be held at 2 to 8 Celsius for about 2 weeks. So obviously there were animal studies that were done on this vaccine to look at effectiveness in preventing Ebola virus. This is just a few of the studies that were done. There are other studies as well. But basically, what they did was they vaccinated the monkeys with various doses of the vaccine, and then they challenged them with live virus 42 days later, and they looked at survival. And, as you could see that, starting at 2 times 10 to the 7th and up, the protection was 100%. At 3 times 10 to the 6th, it was, 8,800, but starting at 2 times 10 to the 7th, it was fully protective. Following the animal studies, there were multiple clinical studies that we'll be going over during our grade presentation that were basically done around the world, in the United States, Canada, Africa, and Europe. With regards to safety, this is something that we'll go over further in our grade summary, as safety outcomes was obviously of interest to our work group. But in general, there is a mild to moderate transient reactogenicity that's commonly reported 24 to 48 hours after vaccination and typically resolves by 7 days. Some of the common signs and symptoms during this period are injection site pain and swelling and erythema, as well as fever or subjective fever, muscle aches, malaise, and headache. Arthralgia and arthritis have also been reported in some vaccinees. And again, we'll go over this in more detail in our grade presentation. And then the vaccine-related SAEs are rare. And again, we'll review that in more depth during our grade presentation. The recombinant virus vaccine, the RSV vaccine virus, has been detected in fluids and bodily fluids. So virus dissemination replication can occur and persist up to 2 to 3 weeks after vaccination. So it has been detected in blood, and of course that's expected. It's a live virus that replicates. And it's been detected as long as 14 days by PCR. And then it's also been seen in urine and saliva as well for the time periods here, as well as synovial fluid. And we'll talk about that again more in our grade presentation, as well as skin vesicles for individuals who developed a vesicular rash. With regards to immunogenicity, there is no known immune correlate for protection, and a measure of immune response that confers protection against EVD is unknown. It's felt that the protective effect of the vaccine is conferred by, is a combination of both the innate and adaptive immune response, response activation. But as measured by ELISA, the GP-specific antibodies begin to rise at around day 14 and can persist for through 24 months. So this vaccine, as many of you know, has been used in the outbreak setting, and I'll just briefly describe the SASUFI trial, which is one of the studies that was that we evaluated by grade. This trial, they reported the results in 2 parts. So it was basically a 2-part phase 3 cluster randomized open label ring vaccination trial. The trial took place in Guinea during the tail end of the 2014-2016 West Africa outbreak. And they used a ring vaccination strategy to administer the vaccine. And part of that was to generate robust data in the setting on efficacy in the setting of a waning outbreak. In the study, a cluster was defined around a confirmed case of EVD. And the primary outcomes was incidence of EVD with onset 10 or more days after randomization. This 10-day period was to account for the incubation for EVD and then the unknown time for the vaccine to develop protective immunity. So the SASUFI, the interim results, clusters were randomized to immediate vaccination or delayed vaccination. And when I say delayed, I mean 21 days after randomization. And in this study, they found vaccine efficacy to be 100% with the confidence intervals that are listed here. And so basically, they had identified a index case, which is a confirmed case. They then defined contacts, which is this first circle here, and then context of contacts. Now, this is your cluster. And so then clusters were then randomized to immediate vaccination, as I mentioned, or delayed vaccination. In the final results paper, so following the interim results and showing the vaccine efficacy of 100%, randomization was actually discontinued at the recommendation of the Data and Safety Monitoring Board, and then all subsequent clusters were offered immediate vaccination. And so basically they reported on, clusters that were randomized and then were not included in the initial report, and then as well as clusters that were not randomized following the drop in randomization. And again, vaccine efficacy was reported to be as 100% with the confidence intervals listed here. So this vaccine is currently being used in the DRC outbreak. Ring vaccination started about a week after the outbreak was declared. The ring strategy has evolved over time, and this is a graphic that was shared with us. So we do have the contacts in the dark blue and the contacts of contacts in the light blue, which is we had seen in the Sasufi trial. But then in addition, we have this third ring of what they label as potential contacts. And so these could be individuals that live in the same area. The vaccine has been administered to over 200,000 people. We don't have any data that I can share publicly in terms of further details on this, on the strategy, on how this vaccine's been working, but we've been told that the vaccine appears to be quite effective, and there's not, the number of SAEs have been reported have been rare. So now we're going to talk a little bit about the parameters for the work group discussions that we've been having for the last several months. So, to set the stage, these are the considerations that we had when we were making our deciding what we were going to focus on for these discussions. The first is that, as we talked about, the suspected virus reservoir does not exist in the United States. The other thing was that most of the individuals that were treated for EBD in the U.S. were responding to a foreign outbreak, and that there is an ongoing outbreak in DRC, and it's considered a public health emergency of international concern, and that there is no EBD outbreak in the United States. So as such, our deliberations focused on pre-exposure vaccination in the U.S. population for people at immediate occupational risk. And as Sharon mentioned, we identified 3 populations at highest risk for potential occupational exposure and for whom policy options are most urgent. And she went over this again, the individuals responding to an outbreak. This includes both, non-governmental organizations like MSF and ALIMA and groups like that that are providing services in the outbreak area, as well as, government persons as well, like CDC, NIH, who are providing epi services and laboratory services and things like that. The other population were individuals who work as laboratorians and support staff at biosafety level 4 facilities in the United States and that handle replication-competent Ebola virus, as well as healthcare personnel at federally designated Ebola treatment centers that are involved in the care and transport of confirmed EBD patients. As Sharon mentioned again, we recognize that there are other individuals and other populations that could be at potential risk. And these include the individuals that Sharon mentioned, and that discussions and recommendations on these groups are still ongoing. So perhaps we could look at the 3 populations a little bit more in depth. So for individuals responding to an outbreak, again, these could be both non-governmental organizations, government organizations. The number of organizations responding to the outbreak will vary in size and based on size and location of the outbreak. So in West Africa, that was quite a large outbreak. There were a lot of organizations involved. So it's hard for me to really estimate the numbers of non-governmental organizations responding. But speaking from the U.S. government perspective alone, there were probably over 4,000, included the military. And then for the current DRC outbreak, the number of U.S. responders is lower, and this is again an estimate. So perhaps at its peak, maybe about 200 NGO personnel and about 300 government personnel. So a little bit about the biosafety level 4 personnel in the United States. So there are 10 BSL-4 labs in the United States with about 350 to 400 lab and support staff. Currently, 8 of these labs handle replication-competent Ebola virus. And then this term of federally designated Ebola treatment centers. So sometimes this has been referred to as, these includes the regional special pathogen centers, and then includes also NIH as well. And these are specialized high-level facilities that are equipped with the infrastructure and the laboratory capabilities and the staff to care for patients with highly hazardous communicable diseases. We estimate that there are about 500 healthcare workers and support staff that work at these facilities. And then again, the healthcare personnel definition, which Sharon reviewed. And that is it. Thank you.
Okay, so thank you very much for that presentation. We will open this up for questions, clarifications, additional data that you'd like. Dr. Bernstein.
Thank you for that presentation. The question I had, you mentioned that it was a live attenuated vaccine but can't cause disease. You also mentioned that it can be detected in certain bodily fluids up to 2 or 3 weeks. What's the clinical significance of that?
Yeah, so for the viremia, it's expected, and most people do clear it within a week or so. But one study did find it as far as 14 days. For the saliva and the urine, certainly it has been detected, as shedding. There weren't any attempts to isolate it. So, again, when something is detected by PCR, it just means that we're able to detect the nucleic acids, and it doesn't necessarily mean, live virus. And in terms of there are some individuals who, after vaccination, did develop a vesicular rash, and from the vesicular rash, they were able to actually isolate virus. So, in terms of what does that translate to, certainly, there is a concern that, particularly with the rash, that with the shedding, there's potential for transmission, and we'll talk a little bit more about this in grade because it was one of our outcomes of interest. And so people will, after people are getting vaccinated through the PREPARE trial, which is a clinical trial that's offering vaccination, there are precautions that are given in terms of contact and what to do if you do develop a vesicular rash. So there will have to be precautions that people will take following vaccination. And then we'll talk a little bit more about this issue of transmissibility in the grade presentation.
Thank you.
Dr. Hunter.
So 2 questions. One is, so you're talking about transmission of viral stomatitis, not of Ebola, correct?
Right. So what I'm talking about is we're detecting the recombinant virus vaccine.
And this is assuming perhaps that the viral strain, if it were to transmit, would cause viral stomatitis. I'm not familiar with the clinical sequela, the worst clinical sequela of that. It sounds like it's not that bad. I don't know.
Yeah, so vesicular stomatitis virus is primarily found in livestock, and so it's an issue for our veterinary colleagues. However, in situations where there have been outbreaks of VSV in livestock, there has been transmission into humans that handle livestock. There's also been some transmission into humans because this virus backbone is a very popular backbone for other vaccines as well. And so there have been transmission into laboratory personnel by accidental exposures. So in humans, the infection with VSV can be asymptomatic, or if it becomes symptomatic, oftentimes it's more like a flu-like illness. But this vesicular type of rash and oral ulcer kind of thing has been seen in humans. It's not, we'll talk about this more later, but typically as I mentioned, arthritis and arthralgia has been seen with this virus. That has not really been seen in humans for VSV. And then in animals, it causes more of the vesicular lesions in the oral mucosa, as well as, I guess, the udders I'm not a vet. But again, in that population, they haven't really seen the arthralgia, arthritis type picture either.
Dr. Fry. Oh, I thought you said your hand went up. Dr. Lee.
So one point of clarification and then one general question. The point of clarification is around the definition for healthcare personnel, and I don't think it's necessarily specific to Ebola, but one thing I noticed, and I realize it says up to, would be to incorporate explicitly physician assistants and nurse practitioners in an updated definition. I don't know what the care team will look like in these Ebola treatment centers, so I'll defer to my colleagues here. The second, it would be, it's interesting because it looks like on slide 27, that the ring vaccination strategy that's evolving now in the DRC, I wonder if one way to think about these categories of people who might be at highest risk in terms of pre-exposure prophylaxis would be around, these are the people that we're really focused on with regard to this pre-exposure vaccination strategy. And as that ring strategy continues to evolve, perhaps, I wonder if we might more generalize this to be more ring 1 as the focus, because we might identify additional subgroups that might benefit from vaccination. I'm just trying to conceptualize it. Does that make sense? I'm trying to align it with the way this is going and understand these three groups certainly fall within what I think is ring 1 here, but if that ring 1 continues to evolve, will we continue to evolve this definition accordingly?
Yeah, I think I understand your question. So I think that we should probably try to make a distinction between what we're trying to make recommendations for and what's going on in Congo. What we're trying to make recommendations for are for pre-exposure. Pre-exposure. So have not been exposed, we vaccinate them in an attempt to protect them for a future exposure. In Congo, it's different. There are doing some pre-exposure vaccination among healthcare workers and frontline workers. But for the most part, when we talk about this ring, it's really post-exposure because the ring is defined around a confirmed case. And that's them because there's an outbreak going on and that's what they need to do. With our situation, given that there is no outbreak in the United States, and then the reservoir is not here, if there is an infection of EVD, we know where it came from. It either came from a foreign outbreak that came to the United States, or it came from a laboratorian, who's working with PSL, with Ebola and had an exposure. So it's really very different. We talk about the SASUFI trial, and we'll talk about this more in the grade presentation because it's the one that showed efficacy. There are many other clinical studies that were done on this vaccine that attempted to show efficacy, but basically, by the time the studies were done, the outbreak was over and there were no other cases. But the SASUFI trial, we mentioned because it's the one that shows efficacy, and it's in the setting of an outbreak, and it's a setting of a post-exposure type of picture.
Yeah, just for clarification, so I apologize. I completely understand the difference between the post and pre-exposure. I guess I'm focused on the fact that I believe that the group we're talking about are people who would be high-risk contacts with close contact with patients or their body fluids. And so it just helps me to harmonize the way we're thinking about these three groups to make sure also that we're not exclusive of other people who might potentially be exposed.
Dr. Adler. Did you? No. Okay, sorry.
So,
Dr. Fry.
Grace, we appreciate those comments, and as we mentioned, we'll be looking at some of these populations in more detail as we go forward. Also, I think there is also a PREPARE trial that folks who are on the front lines can participate in at this point in time, or people who are going to be deployed out. I just wanted to mention that as an aside. But any comments about future discussions are greatly appreciated.
Dr. Bernstein.
You mentioned that untreated, the mortality is 70 to 90%. And then you mentioned that the 9 subjects that were in the United States who got treatment. There was 2 of them died. I know we're talking about a vaccine for pre-exposure, but are efforts for support made a difference in Africa?
Yes, absolutely. So, untreated, so that's with nothing, mortality is 79%. With early supportive treatment alone, the mortality has been as low as 40% with early supportive treatment. In this current DRC outbreak, you probably have heard in the news, they actually did it's called the PALM trial, where they were actually looking at experimental therapies. So they looked at ZMapp, which was used in West Africa, remdesivir, also used in West Africa, and then 2 new monoclonal antibodies, the MAB114 and the Regeneron, and they actually conducted this randomized clinical control trial where the control was ZMapp. And they found that there was a mortality drop, in particular with the 2 monoclonals. And so at this point, they are continuing to give the therapeutics in country, but they're limiting it to the 2 monoclonals. But without that, just with very early supportive care, the mortality can be lower. But the numbers I'm giving you as 70, 90 are untreated, nothing.
Any other questions, comments? All right, very good. So we will proceed to the next presentations, which are the grade presentations and the ETR. Dr. Casabloom, and then I think Dr. Choi will also engage in that one.
Good morning, everyone. This presentation, as he said, is on the grading of recommendations, assessment, development, and evaluation, or GRADE, of the newly licensed Ebola vaccine, which I will refer to as RVSV moving forward in this presentation. The policy question up for consideration is, should pre-exposure vaccination with the RVSV Ebola vaccine be recommended for healthy, non-pregnant, non-lactating adults 18 years of age or older in the U.S. population who are at potential occupational risk of exposure to Ebola virus, species Zaire Ebola virus, for prevention of Ebola virus infection? Now I will walk through the PICO, or Population Intervention Comparison and Outcomes of Interest that were determined by the ACIP Ebola Vaccine Work Group. The population of interest, as I mentioned and Mary mentioned, is healthy, non-pregnant, non-lactating adults 18 years of age or older in the U.S. population who are at risk of occupational exposure to Ebola virus within the following 3 subgroups. The first is individuals responding to an outbreak of Ebola virus disease, or EVD, due to Ebola virus. The second is healthcare personnel that are involved in the care and transport of confirmed EVD patients at federally designated Ebola treatment centers in the United States. And the third group is laboratorians and support staff that work in biosafety level 4 laboratories that handle Ebola virus. The intervention of interest is pre-exposure intramuscular immunization with a single licensed dose of the RVSV Ebola vaccine. The comparison was no vaccine. The outcomes the work group considered critical and that were subjected to analysis were development of Ebola-related symptomatic illness, Ebola-related mortality, which was not analyzed as there was no available data for this outcome, vaccine-related joint pain or swelling, vaccine-related adverse pregnancy outcomes for women who are inadvertently vaccinated while pregnant and women who become pregnant within 2 months of vaccination, transmissibility of the RVSV vaccine virus, surrogate assessed with viral dissemination and shedding of the RVSV vaccine virus, and serious adverse events related to vaccination. There were two additional outcomes that the work group considered important but not critical that included the incidence and severity of oral or skin lesions and the interaction or cross-reactivity with monoclonal antibody-based therapeutics or other vesicular stomatitis backbone vaccines. However, data for these outcomes have not been analyzed to date and will not be included in today's presentation. Of the critical outcome measures that were included in the evidence profile for today's presentation, the 5 outcomes highlighted here were included for meta-analyses: the benefit outcome of the development of Ebola-related symptomatic illness, and the safety outcomes of incidence and severity of arthralgia, incidence of arthritis, and vaccine-related adverse pregnancy outcomes. Of the critical outcome measures that were included in the evidence profile, these 4 remaining highlighted outcomes were included for descriptive analyses only. On December 16, 2019, we executed a literature search in multiple biomedical and interdisciplinary bibliographic databases using a broad and rigorous search strategy that incorporated terms related to vaccination against Ebola virus using the RVSV Ebola vaccine without date or language restrictions. Results were compiled in an EndNote library, and duplicate records were removed. We updated the search on January 31, 2020 to screen recent records that were not captured in the original search. We also attempted to obtain unpublished or other relevant data not included in the search results from subject matter experts and the manufacturer, and received 1 additional record for inclusion in our analysis. Records were included for analysis if they presented data on the RVSV Ebola vaccine and involved immunocompetent adults 18 years of age or older, regardless of pregnancy status, included data for the intervention of interest and data relevant to the outcome measures being assessed, and reported primary data from comparative or single-arm studies, randomized control trials, prospective or retrospective cohort, case control, or cross-sectional studies. In total, 1,818 records were identified through our database searches, and the 1 unpublished record that I mentioned was identified through other sources. A total of 1,742 of these records were excluded during title and abstract screening, leaving 77 full-text articles that were assessed for eligibility through full-text review. Of these, 59 full-text articles were excluded for the reasons shown in the large box on the right. In total, 18 articles that presented data from 11 studies were included in qualitative synthesis, while 9 articles that presented data from 8 studies were included in quantitative synthesis or meta-analysis. The grade approach for assessing the type or quality of evidence involves consideration of several criteria. Assessing the type or certainty level of the body of evidence for each outcome begins with the study design. Randomized control trials are initially classified as evidence type 1, or high certainty, and observational studies as evidence type 3, or low certainty. Following the identification of the initial evidence type, the body of evidence for each outcome is assessed and downgraded if there's uncertainty about any of the 5 following criteria: risk of bias, inconsistency, which considers statistical heterogeneity in I-squared, or the variation across studies due to heterogeneity greater than chance. Indirectness, or the generalizability of the body of evidence to the original PICO components. Imprecision, which considers the fragility of the relative and absolute effect measures as they relate to the 95% confidence intervals and optimal information size. And publication bias. The body of evidence from observational studies may be rated up due to dose-response gradient, large or very large magnitude of effect, or residual confounding, considered here under other considerations. After assessing on the criteria I just described, the body of evidence will be assigned an overall evidence type or certainty level. To provide context for interpretation of this, type 1 or high certainty evidence means that we're very confident that the true effect lies close to that of the estimate of effect. Type 2 or moderate certainty evidence means we are moderately confident in the effect estimate. Type 3, or low certainty evidence, means our confidence in the effect estimate is limited, while Type 4, or very low certainty evidence, means we have very little confidence in the effect estimate. As a reminder, we're not measuring how well the individual studies were conducted, but rather how much confidence we have in the estimates of effect from the body of evidence across each outcome. For the purposes of the evidence assessment, RCT, or randomized control trial, refers to a trial which randomizes participants to an active intervention or a placebo or unvaccinated comparator arm. Observational studies refer to one-arm studies, studies for whom participants were not randomized, or studies that did not provide disaggregated data to allow for the comparison between the randomized arms. Evidence was also considered observational if only data from the vaccinated study arms were included in analysis for a given outcome. The first outcome that I will discuss is the development of Ebola-related symptomatic illness. As Mary mentioned, there was one published study with an unvaccinated comparator that was included for the body of evidence for this outcome. Hanau-Restrepo 2017, which is the publication associated with the SASUFI trial in Guinea. This was a two-part phase 3 cluster randomized open-label ring vaccination trial. The initial study involved contacts and contacts of confirmed Ebola virus disease or EVD cases that were randomized to either immediate or delayed vaccination. Delayed vaccination was defined as vaccination that occurred 21 days after randomization. A follow-up study included immediate vaccination following cessation of the randomized trial. The primary outcome was the incidence of EVD with onset of 10 days or more following randomization. The 10 days, as Mary mentioned, accounts for the average incubation period of Ebola and the unknown time for the vaccine to induce protective immunity. Now I'll walk through this table that presents the body of evidence for the outcome of development of Ebola-related symptomatic illness from this one published study, Hanau-Restrepo 2017. I will focus on the development of EVD 10 days or longer after randomization, or for non-randomized participants, 10 days or longer after inclusion in the ring. Because as explained in the previous slide, these 10 days account for the incubation period and unknown duration to immunity. Out of 3,775 participants within 70 clusters that received immediate vaccination between the randomized and non-randomized participants, 0 participants developed EVD 10 days or longer after randomization. In contrast, out of 4,507 participants within 104 clusters that were delayed or never received the vaccine, 23 participants within 11 clusters developed EVD 10 days or longer after randomization. Now focusing only on the participants within the randomized clusters, out of 2,108 participants within 51 clusters that received immediate vaccination, 0 developed EVD greater than 10 days after randomization. In contrast, of 3,075 participants within 47 clusters that were randomized to delayed vaccination, 16 participants within 7 clusters developed EVD greater than 10 days after randomization. This data equate to a calculated vaccine efficacy of 100% with the confidence interval shown here. Given that this was a cluster randomized trial where the units of randomization were clusters, we present randomized cluster-level data in the first row of this table. Using the randomized cluster-level data presented on the previous slides, it equates to a risk ratio of 0.06. Because the population in this study consists of contacts and contacts of EVD cases and used a ring vaccination study that may include post-exposure vaccination, as we've discussed, we downgraded one level for indirectness to the U.S. population and our intervention of interest, which is pre-exposure vaccination. For this cluster-level data, there were few events reported, and the data do not meet the optimal information size and suggest fragility of the estimate, and the confidence interval crosses 1 and contains the potential for desirable as well as undesirable effects, so we downgraded 1 level for imprecision. To provide some context, as was discussed in Mary's presentation, there were few events of confirmed Ebola reported even among the unvaccinated arm because the study was conducted at a time when the 2014 to 2015 West Africa outbreak was waning in Guinea. Taking into account this assessment, the overall assessment of this body of evidence at the randomized cluster level to address the outcome of development of Ebola-related symptomatic illness is type 3 or low certainty evidence. So from the same study, we present participant-level data from the randomized clusters that support there is a benefit of vaccination among those that are vaccinated, which was considered observational because, as I discussed, the units of randomization within the study were clusters. Because we see a very precise decrease in the non-randomized group, we did not rate down for imprecision at the participant level. We rated down 1 level for indirectness for the same reason as the cluster data. However, the concerns with indirectness do not pose an inflationary effect, and therefore the evidence could be rated up based on the very large magnitude of effect from the 96% relative risk reduction. Taken together, overall certainty was upgraded 2 levels to type 2 or moderate certainty evidence for this participant level data. The next outcome that I will discuss is the incidence of arthralgia, which was assessed with the incidence of arthralgia or joint pain that was solicited within 0 to 42 days. This forest plot presents the results of a meta-analysis of 6 studies that solicited arthralgia within 0 to 42 days. It's important to note that across these studies, definition of arthralgia, as well as length and time of follow-up, varied between studies. We did conduct an analysis that stratified by duration of follow-up, and it did not have an impact on effect estimates for this analysis. However, there is a concern that pulling these data may not represent the true incidence of arthralgia among participants because of the variability in follow-up time. Additionally, the data presented here are varying across doses or the plaque-forming units of the vaccine. However, after conducting a separate analysis that stratified by dose, there does not seem to be a dose response or effect on this outcome. Taken together, the calculated risk ratio from these 6 RCTs was 2.55. There were also 2 non-randomized studies with non-vaccinated comparators that were analyzed separately with a calculated risk ratio of 1.63. Additionally, across 7 studies that did not have a comparison group, 1,546 out of 8,329, or 16% of vaccinated participants reported arthralgia. Now I will walk through the evidence table for the assessment of the body of evidence for outcome 2, incidence of arthralgia. Looking at the body of evidence for the 6 randomized trials, overall 1,874 vaccinated participants, 316 or 16.9% reported arthralgia, compared with 42 out of 891 or 4.7% of non-vaccinated participants. This equates to a relative risk of 2.55 and an absolute risk of 73 more events of arthralgia out of 1,000 people. This body of evidence was downgraded 1 level for a concern for risk of bias because a lack of blinding in participants, healthcare personnel, and outcome assessors in 2 studies may have influenced events reported for this subjective outcome. Additionally, there's concern for underreporting in 1 study that only solicited arthralgia at 1 week and 1 month for the majority of participants that may have led to underreporting of events. Due to concerns with the heterogeneity with an I-squared of 70%, we downgraded 1 level for inconsistency. Because the 95% confidence interval crosses 1 and includes a potential for possible harms as well as benefit, we downgraded 1 level for imprecision. Overall, this body of evidence was assessed to be type 4, very low certainty evidence. Looking at the body of evidence for the 2 observational studies, overall, among 469 vaccinated participants, 75 or 16% reported arthralgia compared with 8 out of 99 or 8.1% of non-vaccinated participants. This equates to a relative risk of 1.63 and an absolute risk of 51 more events of arthralgia out of 1,000 people. Because there were few events reported, which suggests fragility in the estimate, we downgraded 1 level for imprecision. Overall, this body of evidence was assessed to be type 4, very low certainty evidence. The third outcome I will discuss is severity of arthralgia, assessed with the incidence of severe grade 3 arthralgia solicited between 0 to 42 days and defined as significant joint pain or discomfort that prevents daily activity. For background, arthralgia is described on a grade 1 to 4 scale. Grade 1, mild, no interference with activity. Grade 2, moderate, some interference with activity. Grade 3, significant, prevents daily activity. And grade 4 is potentially life-threatening and requires medical consultation and/or hospitalization. There were no reports of grade 4 arthralgia across the body of evidence. This forest plot presents the results of a meta-analysis of 4 studies that reported on incidence of severe arthralgia within 0 to 42 days. It's important to note that similar to the previous outcome, across these studies, time of follow-up and dose or PFU of vaccine used varied between studies. However, similar to the previous outcome, these did not have an impact on effect estimates. Taken together, the calculated risk ratio from these 4 RCTs was 6.4. There were also 2 non-randomized studies with non-vaccinated comparators that were analyzed separately and reported no events of grade 3 arthralgia among 469 vaccinated and 99 non-vaccinated participants. Additionally, across 5 studies that did not have a comparison group, 7 out of 7,209, or 0.1% of vaccinated participants, reported grade 3 arthralgia. Now I will walk through the evidence table for the assessment of the body of evidence for outcome 3, severity of arthralgia. Looking at the body of evidence for the 4 randomized trials, overall, among 333 vaccinated participants, 2, or 0.6, reported severe arthralgia, compared with 0 out of 264 non-vaccinated participants. This equates to a relative risk of 6.4 and an absolute risk of 0 more events of severe arthralgia out of 1,000. This body of evidence was downgraded 1 level for a concern for risk of bias because of lack of blinding, as I discussed before. Because of there being a concern for fragility in the estimate due to the few number of events reported, we downgraded 1 level for imprecision. Overall, this body of evidence was assessed to be type 3, low certainty evidence. Looking at the body of evidence for the 2 observational studies, overall, no events of grade 3 arthralgia were reported among 469 vaccinated and 99 non-vaccinated participants. Because there were no events reported among vaccinated and non-vaccinated participants, it suggests fragility in the estimate, and we downgraded 1 level for imprecision. Overall, this body of evidence was assessed to be type 4, very low certainty evidence. The next outcome that I will discuss is the incidence of arthritis, which was assessed with an event of arthritis reported within 5 to 56 days of follow-up. This forest plot presents the results of a meta-analysis of 4 studies that solicited arthritis within 5 to 56 days. It's important to note that each of these studies defined and diagnosed arthritis with considerable variability, described here in these bullets on the screen. Additionally, the time of follow-up and dose or PFU of the vaccine used varied between the studies. However, similar to the previous outcome, these did not have an impact on the effect estimates. Taken together, the calculated risk ratio from these 4 RCTs was 1.8. There were also 2 non-randomized studies with non-vaccinated comparators that were analyzed separately and had a comparable effect size and lower precision. Additionally, across 2 studies that did not have a comparison group, 2 out of 50, or 4% of vaccinated participants reported arthritis. Additionally, 3 published studies reported on the detection of vaccine virus in synovial fluid. This data was not included in the evidence tables that follow. However, we felt that it was directly applicable to this outcome and may support causality between vaccination and arthritis, so we're presenting it descriptively here. Across this body of evidence, vaccine virus has been detected by RT-PCR in 4 out of 7 vaccinated participants that have had synovial fluid tested. Viral isolation was attempted on 1 synovial fluid specimen and was negative. Now I will walk through the evidence table for the body of evidence for this outcome for incidence of arthritis. Looking at the body of evidence for the 4 randomized trials, overall, among 1,776 vaccinated participants, 39 or 2.2% reported severe arthralgia compared with 16 out of 868 or 2.1% of non-vaccinated participants. This equates to a relative risk of 1.8 and an absolute risk of 23 more events of arthritis out of 1,000 people. This body of evidence was downgraded 1 level for a concern for risk of bias because studies used variable definitions and methods for diagnosing and reporting arthritis, and for lack of blinding in participants, healthcare personnel, and outcome assessors in 2 studies that may have influenced events reported for this outcome. Because the 95% confidence interval crosses 1 and may include a potential for possible harms as well as benefits, we downgraded 1 level for imprecision. Overall, this body of evidence was assessed to be type 3 low certainty evidence. Looking at the body of evidence for the 2 observational studies in the next row, overall, 43 out of 520 vaccinated recipients reported arthritis compared to 3 out of 107 unvaccinated participants. This equates to a risk ratio of 2.06 and an absolute risk of 33 more events of arthritis out of 1,000 people. Because there is concern for fragility in the estimate due to the few number of events reported and that the 95% confidence interval crosses 1 and includes a potential for possible harms as well as benefits, we downgraded 2 levels for imprecision. Overall, this body of evidence was assessed to be type 4, very low certainty evidence. The 5th outcome I will present data on is the vaccine-related adverse pregnancy outcomes for women inadvertently vaccinated while pregnant and women who become pregnant within 2 months of vaccination that was assessed with the incidence of pregnancy loss, defined as spontaneous abortion and stillbirth. There was 1 study with a comparator included in the body of evidence for this outcome, Lagarde-Williams 2020. This was a non-randomized sub-study of the Sierra Leone trial to introduce a vaccine against Ebola. In this study, 14 out of 31, or 45% of pregnant women who received immediate vaccination experienced pregnancy loss, compared to 11 out of 33, or 33% of unvaccinated pregnant women. Overall, the rate of pregnancy loss between these groups was not significantly different. Among live births, no external congenital anomalies were detected among either group. Further studies with larger sample sizes are needed to rule out a meaningful difference in the percentage of pregnancy loss, pregnancy complications, or birth defects. There were 3 additional studies that reported on this outcome that did not have comparison groups. Among these 3 studies, there were 3 adverse pregnancy outcomes out of 20 pregnancies in 19 women. However, no conclusions can be made regarding the relationship between vaccination and adverse pregnancy outcomes based on these data. The body of evidence for outcome 5, vaccine-related pregnancy adverse events, is summarized here. In this 1 observational study with a comparator, 14 out of 31, or 45% of pregnant women who received immediate vaccination experienced pregnancy loss compared to 11 out of 33, or 33% of unvaccinated pregnant women. This equates to a relative risk of 1.35 and an absolute risk of 117 more events of pregnancy loss out of 1,000 people. We downgraded one level for indirectness because this study did not differentiate between spontaneous abortions that included induced abortion and stillbirth, and the outcome may not accurately distinguish between events due to the vaccine. Additionally, because of there being a concern for fragility in the estimate due to the few number of events reported, and that the 95% confidence interval crosses 1 and includes a potential for possible harms as well as possible benefits, we downgraded 2 levels for imprecision. Overall, this body of evidence was assessed to be type 4, very low certainty evidence. The next outcome, 6A, I will discuss is the transmissibility of vaccine virus, with a surrogate of vaccine virus dissemination assessed with detection of RVSV in blood or plasma by RT-PCR. Data from 8 studies were included for the body of evidence for this outcome. Across these 8 studies, on day 7 post-vaccination, 32 out of 691 vaccinated participants, or 4.6%, were RT-PCR positive for vaccine virus. On day 14 post-vaccination, 1 out of 501, or 0.2%, of vaccinated participants were RT-PCR positive for vaccine virus. Additionally, one study performed viral isolation on selected blood specimens, and all were negative. To summarize the body of evidence for the surrogate outcome of detection of RVSV in blood or plasma by RT-PCR, the longest recorded positive is 14 days post-vaccination. While these 8 studies include both randomized controlled trials and non-randomized studies, for the purposes of this outcome, only data from the vaccinated arms were included for analysis, so as discussed previously, the studies were considered observational for this outcome. We downgraded one level for risk of bias because of concern for incomplete outcome data, as not all who received the vaccine were tested on a given day. We also downgraded 2 levels for indirectness because the outcome of interest to the work group was transmissibility of the vaccine virus to humans or animals. There is no data that reports on transmissibility, so viral dissemination and shedding is assessed as an indirect surrogate. Additionally, RT-PCR positivity is not synonymous with infectivity. Overall, this body of evidence was assessed to be type 4, very low certainty evidence. Outcome 6B is the transmissibility of vaccine virus with a surrogate of vaccine virus dissemination assessed with detection of RVSV in saliva and urine by RT-PCR. Data from 4 studies were included for this body of evidence for this outcome. Across these 4 studies, on day 7 post-vaccination, 6 out of 257 vaccinated participants, or 2.3%, were RT-PCR positive for vaccine virus in saliva, while 2 out of 246, or 0.8%, were positive in urine. On day 14 post-vaccination, 1 out of 98, or 1%, of vaccinated participants were positive in saliva, while 0 out of 98 were positive in urine. To summarize the body of evidence for the surrogate outcome of detection of RVSV in saliva and urine by RT-PCR, the longest recorded positive in saliva is 14 days post-vaccination, and the longest recorded positive in urine is 7 days post-vaccination. Like the previous outcome, only data from the vaccinated arms were included for analysis, so studies were considered observational for this outcome. We downgraded one level for risk of bias because of concern for incomplete outcome data, as not all received the vaccine were tested on a given day. We also downgraded 2 levels for indirectness because, like the previous outcome, there's no data that reports on transmissibility, so viral dissemination and shedding is assessed as an indirect surrogate, and RT-PCR positivity is not synonymous with infectivity. Overall, this body of evidence was assessed to be type 4, very low certainty evidence. The final outcome I will be discussing, outcome 7, is vaccine-related serious adverse events. Across the body of evidence, 12 studies with unique populations reported on vaccine-related serious adverse events. Out of 19,184 people that received the vaccine across these 12 studies, 3 SAEs were judged to be related or possibly related to the vaccine were reported. 2 of these were related to vaccination and included a febrile reaction and anaphylaxis, both of which was resolved without sequelae. One was judged to be possibly related to the vaccine, an influenza-like illness, which also resolved without sequelae. In summary, the majority of studies did not report any vaccine-related SAEs. To summarize the body of evidence for the outcome of vaccine-related serious adverse events, vaccine-related serious adverse events are an uncommon occurrence. Across 12 studies, 3 out of 19,184, or 0.02%, of vaccinees were judged to have an SAE related to or possibly related to vaccination. Like the previous outcome, only data from the vaccinated arms were included for analysis, so the studies were considered observational for this outcome, and we did not downgrade across any of the criteria. Overall, this body of evidence was assessed to be type 3 low certainty evidence. This slide presents the references that were included in our analyses that were referenced throughout the presentation in the evidence tables. And this completes the grade presentation. We ask that you hold your questions until after the next presentation on the evidence to recommendations. Thank you for your attention.
Hello. So I will be going over the ETR portion. So again, the policy question, which Caitlin went over, should pre-exposure vaccination with the VSV vaccine be recommended for healthy, non-pregnant, non-lactating adults 18 years of age or older in the U.S. population who are at potential occupational risk of exposure to Ebola virus species Zaire Ebola virus? And then again, the PICO, which again, Caitlin went over, and I will spare you from hearing that again. So the first criteria was, is Ebola virus disease due to Ebola virus a problem of public health importance? And so for this question, we consider the following. Ebola virus, as I mentioned, is the most lethal of the 4 viruses that cause EVD in humans. It's highly transmissible. In infected people, you can find it in the bodily fluids, in all bodily fluids. The disease can be quite severe and death can be rapid, occurring as soon as 7 to 10 days after symptom onset. In survivors, the virus has been known to persist in immune-privileged sites, and in some instances, this has led to continued disease transmission and disease recrudescence. And in addition, there is no FDA-approved treatment. The virus is an international public health threat. It is responsible for the majority of EBD outbreaks that have been reported, 18 out of 28 or 64%, to include the largest outbreak in history. The virus has infected over 31,000 persons and resulted in over 12,000 deaths. And then the current outbreak is also responsible for the current outbreak, which is a public health emergency and continues to be a public health emergency. And in that outbreak, we have over 3,000 persons infected and over 2,000 deaths. The virus is also a U.S. public health threat. We know that there are 11 individuals who were infected with the virus and treated in the United States. As I mentioned, all of them were associated with the West Africa outbreak. Majority were infected in West Africa, and 2 were infected in the United States when caring for a returned traveler. And then in addition to the 11, we have multiple individuals who were repatriated to the United States during both West Africa and the current DRC outbreak because of high-risk exposures to the virus, but none tested positive. And so is this virus a public health threat? We would say yes. So the next section is benefits. So how substantial are the desirable anticipated effects of vaccination? And as Caitlin mentioned, we have one study that was evaluated using GRADE that provided evidence on vaccine efficacy. And this study at the participant level demonstrated a protective effect with basically a 96% risk reduction. And so we feel that the anticipated effects are large. With regards to harms, how substantial are the undesirable anticipated effects? From Caitlin's presentation again, we know that arthralgia is more commonly reported among vaccinees, and the risk ratio is here for the randomized control trials. Severe arthralgia is also more commonly reported among vaccinees, although it seems to be uncommon. Arthritis is also more commonly reported among vaccinees. With pregnancy loss, it appears that in vaccinated women doesn't seem to be as significantly higher than in non-vaccinated women. But again, as she mentioned, the data is quite limited in this. We also know that the recombinant vaccine has been detected post-vaccination in blood, saliva, urine, and synovial fluid, and that vaccine-related SAEs are rare. So for this, we graded it to be moderate. Next question is, do the desirable effects outweigh the undesirable effects? And to make this determination, we consider the following: the demonstrated protective efficacy of the vaccine, the high severity of illness in people who contract EVD, the high transmissibility of the virus in infected individuals, and the issue of virus persistence and potentially instances of continued disease transmission and disease recrudescence that we have seen, as well as the lack of an FDA-approved treatment in the setting of rare SAEs related to the vaccine. And so based on that, we felt that it does favor intervention. With regards to overall certainty of evidence, for effectiveness of the vaccine, we have one study that used GRADE to look at efficacy and that it demonstrated a protective effect from vaccination. Based on the participant level, the overall certainty for the evidence was moderate, and so we feel that the certainty for effectiveness is moderate. With regards to safety, certainty of the evidence for safety, as Caitlin went through, we had several outcomes that were related to safety. The first one was arthralgia, and as she noted, arthralgia was more commonly reported among vaccine recipients. The certainty level for this evidence, as she mentioned, was low, very low, and that some of this may be due to the variability among the studies that were included in the meta-analysis in terms of definition, evaluation, and availability of specialized care to evaluate arthralgia. So regarding the outcome of severe arthralgia, as Caitlin mentioned, is more commonly reported among vaccine recipients compared to placebo or the unvaccinated, but overall it appears to be uncommon. The certainty level for this was low or very low, depending on whether you're looking at randomized clinical control trials or the observational studies. And again, some of this low certainty may be due to the variability between the studies included in the analysis in terms of the evaluation of arthralgia and the timing in which arthralgia was ascertained. With regards to arthritis, again, arthritis was more commonly reported among vaccine recipients compared to placebo. We also know that the recombinant VSV virus has been detected by PCR in synovial fluid in a few vaccinated individuals. The certainty of the evidence, as Caitlin presented, was either low or very low, depending on whether you're looking at randomized clinical control trials or observational studies. But again, some of this may be due to the fact that these studies, although they all looked at arthritis, the definition of arthritis, the methodology used to diagnose arthritis, the availability of specialized care, rheumatology consults, radiographic imaging, it varies significantly between the studies. With regards to pregnancy loss, as Caitlin mentioned, pregnancy loss among vaccinated women was not significantly higher than pregnancy loss among unvaccinated women, and the certainty of this evidence was very low. And then with regards to severe adverse events, as she mentioned, across 12 studies and over 19,000 vaccinated individuals, there were 2 vaccine-related and 1 possibly vaccine-related SAE, all of which resolved without sequelae. The certainty of evidence for this was low. But again, as she mentioned, part of this is because we extracted from the vaccinated arm only, thus rendering the data to be observational, and that vaccine-related SAEs are rare. With transmissibility of the vaccine virus, again, as she mentioned, there is no data availability on vaccine transmissibility to non-vaccinated persons or animals. So we looked at viral dissemination and shedding as an indirect surrogate for this outcome. The certainty of the evidence was very low. Again, it's because the outcome data was only collected from the vaccinated arm, thus rendering the data observational. So in summary, overall certainty of the evidence in terms of the safety of the intervention was very low. The next question was target population sentiments. Does the target population feel that the desirable effects are large relative to the undesirable effects? So the first thing is there is no CAP survey. There is no knowledge, attitudes, and practices surveys that have been done among our three populations of interest on this subject. Within our work group, we had several discussions about this, and our feeling was that persons responding to EVD outbreaks and healthcare providers, personnel at federally designated Ebola treatment centers will likely think that the desirable effects outweigh the undesirable. We think this because several of them have enrolled in a clinical trial, the PREPARE clinical trial that is offering vaccination. In addition, the majority of the EVD patients treated in the US were either responding to an outbreak or were healthcare workers. With regards to our BSL-4 personnel population, we know from our work group discussions that the response to vaccination has been mixed. Some have enrolled in PREPARE, so they have been vaccinated through the clinical control trial. So there are people that are open to vaccination. There are others who wanted to enroll and PREPARE, but were unable to do so because of the logistical challenges. Right now, for the PREPARE trial, there's only 3 clinical sites in North America. It's NIH, Emory, and Winnipeg. So the logistical challenges of that travel was a barrier to them. But there's also been anecdotal reports of some people just declining to be vaccinated because they felt that the additional level of protection afforded by vaccination in the backdrop of the strict biosecurity measures that are already in place at BSL-4 laboratories was felt to be minimal compared to the potential undesirable effects. So in order for this criteria, we considered the following things that I just reviewed here, and we felt that it varies. We are looking at 3 pretty different populations. So the next question is there important uncertainty about or variability in how much people value the main outcomes? So again, as I mentioned, we feel that individuals responding to an EVD outbreak and healthcare personnel at federally designated Ebola treatment centers will likely feel that the desirable effects are large. Among the BSL-4 population, again, amongst our work group discussions, we know there was a mixed response, but we think that most would think that the desirable effects are large relative to the undesirable. And so for this, we made the determination that we think there is probably no important uncertainty or variability. So stakeholder sentiments, is the intervention acceptable to key stakeholders? Again, as I mentioned earlier, there is no CAP survey. We feel that that for the majority of the 3 populations that we have looked at, that the vaccination is acceptable to them. We also know that the NGOs and federally designated Ebola treatment centers and governmental organizations like CDC and BSL-4 laboratories have been supportive of their personnel participating in the PREPARE trial. So for this, we said yes. With the next question was resource allocation. Is there intervention or reasonable and efficient allocation of resources? A cost-effective analysis was not performed for this vaccine as it's intended for use in preparedness scenarios in limited populations and not as a routine vaccination for the general population, and that at this time the vaccine will be stored and made available through the US government. So there was, we said yes for this one. Feasibility. So as it appears now, licensed vaccine will likely become available Q3, Q4 of 2020. The vaccine is currently available through the PREPARE clinical trial. There are ongoing discussions to identify a mechanism that would allow for limited quantities of investigational labeled vaccine to be made available to ACIP recommended populations in the interim between ACIP recommendation and availability of licensed product. So for balance of consequences, we felt that the desirable consequences probably outweigh the undesirable consequences in most settings. Is the next criteria was sufficiency of information. Is there sufficient information to move forward with the recommendation? To make this determination, we considered the following. We do have available efficacy data on outbreak settings, and we do have safety data on 19,000 plus vaccinated persons in US, Europe, Africa that we evaluated using GRADE, and so we said yes. And that is the end of that presentation.
Thank you very much for those presentations. So we'll open this up to questions, clarifications from the committee. Let me begin by asking the first question, if I may. So can you give us some information regarding the duration of the arthralgia or arthritis that these patients had?
I'm sorry, can you repeat the question?
Yes, so could you give us some information regarding the duration of the arthritis or arthralgia presented in these patients? Was it short? Can you give a specific date, days or weeks?
Sure. In general, most of the arthralgia events reported were mild and resolved over a short period of time. There were instances of arthralgia that persisted for over more than a month's time and also recurred, so resolved and then was reported again. And I'm happy to follow up with the exact numbers if needed.
Dr. Talbot.
So it's interesting to me that we talked about these studies being done in healthy populations. I'm assuming that means immunocompetent, but do we have any idea about other comorbid conditions?
What other comorbidities?
So if someone has severe heart disease, is this virus safe? Do we have any data in those populations? Well, I'm assuming the Ebola virus would be bad.
Dr. Fry would like to offer comment.
I meant the recombinant virus vaccine.
Sorry,
Dr. Fry,
I don't
comment.
think we have that data, and it's only being recommended and presumably being given to people who are otherwise healthy and not pregnant.
I guess I'm asking, what is your definition of healthy?
Oh, that's a good question. So I'm not sure that we've actually defined what healthy means. For clinical trials, it's usually pretty strict. And so, to be quite honest, I'm not sure that we have a definition for healthy. We could go back to the PREPARE trial and look at their definition of healthy, but in the United States, that would probably be different from, international populations. So typically in the United States, healthy means without certain most comorbidities. Sometimes they allow things like hypertension if it's well controlled. Certainly non-pregnant, non-lactating.
I just think it'd be helpful to have a definition to go along with that for providers.
Great. Dr. Szilagyi. Yes.
Thanks for a very clear, very clear presentation. Also, a couple questions about the arthritis, especially outcome 4. I did have that question about did they follow patients longer than 56 days? I think that's an important measure. But the other thing is the incidence rates for arthritis in outcome 4 were 2.2% versus 2.1%. That doesn't calculate to a risk ratio of 1.8. it's actually much safer if the incidences were correct. So I would just go back and check those numbers. It's under outcome 4. And I did have a question about vaccine supply. I know it will be available, but if there is a larger outbreak, are you going to at some point talk about whether the supply would be large enough if there are more personnel there, or if there would be a need for a larger than the current targeted population?
And thank you for that. And as you mentioned, and we presented in the presentation, there was considerable variability in the methods that were used to follow up and clinically diagnose arthritis. And so some of the references did follow up patients for more than 56 days and did report. There were select reports, few reports of recurrent arthritis and durations of longer than the 56 days, and happy to follow up with those exact numbers for you.
Is Dr. Beth Ann Kohler here from Merck to comment about these issues of arthritis and arthralgia? We want to offer, there she is, here she comes. And let me add one other question to this, since we're talking about it. That is, were individuals screened for pre-existing arthralgia or arthritis conditions? And if so, were those individuals more at risk for this? Dr. Kohler.
Okay, thank you. Can you hear me okay? So with regards to arthritis and arthralgia, there was long-term follow-up included in many of the studies where the subjects continued to be followed out for at least 6 months in the US-based study, for example. So there were some recurrences, as was alluded to, for arthritis events, including things like trigger finger and things like that were observed out even 2 years in the Geneva cohort. So I think we do have based on the limited sample size, a reasonable a view of the duration and recurrence of arthritis events.
Thank you. Dr. Paling.
I also want to thank you and the entire working group for a very comprehensive presentation. My question is about the data on transmissibility. Was that based on the PCR studies?
Yes, so there were no data available on transmissibility of the vaccine virus, so the work group decided to assess the detection of vaccine virus by RT-PCR in the blood, saliva, and urine.
What wasn't included in the presentation, but I'm thinking about, because we've been talking, the backbone is of vesicular stomatitis viruses. What is the incidence of the stomatitis and the vesicular outbreaks?
Sure, and this was, so for the purposes of today's presentation, we did not do the comprehensive systematic review on that outcome, on the outcomes of incidence of the oral and skin lesions, just because those were lower in importance to our work group, but it is something that we plan to address in the future.
Dr. Cohen would like to ask a clarifying question.
Can I just ask a clarifying question to Dr. Kohler about the overall, can you remind us of what the overall incidence of arthralgias was, and then what proportion of the persons who had arthralgia had longer term, greater than 1 week, or recurring events?
Okay, so the overall incidence of arthralgia across the program, and I actually wish I'd brought my notes with me, specific from the U.S. Prescribing information, is in the ballpark of 10 to 15% of individuals develop arthralgia, and typically that resolves within the first 7 days or so. Sorry, the rest of the question?
Just when you say typically, what is the proportion of persons in whom arthralgias or arthritis resolves, and what is the proportion where it is longer term?
Yeah, I would have to go back and get that specific information for you, but I'll be happy to do that.
Great.
Dr. Fry. Dr. Fry, did you have, okay. Dr. Sanchez.
So I was just wondering, the vesicular stomatitis virus has been used for other vaccines, and I was wondering if arthritis or arthralgias have also been seen with those other vaccines.
So I did look this up, and so I did read other papers on this, and they did not seem to find that. In the one paper that I looked at, that was a review that looked at other VSV-based vaccines, that arthritis was not seen there. And as I mentioned earlier, arthritis was not seen in humans affected with the VSV vaccine. And so the initial paper that looked at arthritis and the synovial fluid issue in vaccinated individuals postulated that this may be something that is specific to the VSV recombinant, this combination of the VSV plus the glycoprotein of the Zaire behaving a little bit differently than would have been expected, because it was not seen in with the VSV in humans or animals.
Dr. Bernstein.
I had two questions, and one is just following up on the arthralgia arthritis. The patients who had arthralgia did not evolve into arthritis. Are they the same patients or are they different patients?
And of course, happy to also defer this to Dr. Kohler, but I can say that in many of the reports, there wasn't individual level data. And so there were reports of arthralgia and arthritis, but it wasn't clear in some cases if they were the same people. And I'm happy to pass this on to Dr. Kohler to give more.
Dr. Kohler, please comment.
Yes. So often they were the same individuals who experienced some joint pain and then had evidence of joint swelling. Not in all cases, but in many of the cases, it was the same individuals. And actually, I was just remembering an earlier question that if perhaps I could address.
Please do.
Whether there was evidence that a prior joint injury led to an increased risk of arthritis and arthralgia. And in fact, we did an analysis in the large phase 3 study conducted in the US and did find that prior damage to joints and or being a woman actually led to an increased risk of arthritis.
Thank you for that clarification. Dr. Fink, please, from the FDA.
Sure. So I just wanted to mention that in the data that FDA evaluated in the BLA submission, we looked at events of arthralgia and arthritis and found that arthritis specifically occurred at a range of 0% to 24% of subjects. With most studies that we evaluated, the arthritis rate was less than 5%. There was one outlier, a study in Switzerland, where it occurred at a rate of 24%. That outlier study also had the highest proportion of subjects who had prolonged arthritis, which was 6 subjects out of 24.
Thank you, Dr. Fink. Dr. Messonnier.
Maybe before FDA puts down the phone, 2 other questions related to questions that were asked. Did FDA consider pre-existing conditions and whether there are any that should be contraindications? And did FDA consider pregnancy categories? Can you speak to both of those issues?
Sure. So in terms of pre-existing conditions, we did not consider there to be any pre-existing conditions for which the vaccine would be contraindicated based on the available data, and considering the severity of Ebola disease and the benefit-risk considerations. In terms of individuals with pre-existing conditions, there were individuals in the safety database that had some pre-existing conditions, including HIV infection and other immunocompromising states. I think it's also worth noting that in the Ebola Sasufit trial, There were no exclusion criteria related to pre-existing conditions other than having a medically significant condition that was resulting in hospitalization or requiring treatment for Ebola disease, obviously. In terms of pregnancy, our FDA labels no longer have pregnancy categories. We have descriptions of data and risk considerations related to human and animal data with regard to pregnancy. The non-clinical or animal studies that were done to assess for reproductive toxicity did not raise any concerns with regard to use in pregnancy, but as was mentioned during the presentation of the GRADE analysis, there is pretty limited data on pregnancy outcomes in humans who have been vaccinated, and so not enough data to make any firm conclusions about risks from exposure to the vaccine during pregnancy. That being said, in considering the overall risk and benefit balance, the vaccine indication does include women who are pregnant who are at risk of Ebola exposure.
Thank you. Dr. Schaffner.
Bill Schaffner of the National Foundation for Infectious Diseases. First, let me join in congratulations for a very clear presentation. The emphasis here has been on pre-exposure prophylaxis, and I wonder about post-exposure prophylaxis. Were there to be another episode such as happened in Dallas, I would imagine there would be a great interest in using this vaccine in a post-exposure circumstance. Has the working group considered including post-exposure prophylaxis?
So for the purposes of the work group, we focus our discussions on pre-exposure. Certainly, the vaccine, as I mentioned in DRC, is used in essentially a post-exposure method with the rings and the clusters. But for the purposes of our work group discussions, we focus on pre-exposure and identifying the three populations at highest risk. The issue of post-exposure is something that we will continue to address as the work group meets, as we also discuss the other populations for whom we would potentially suggest recommendations.
Dr. Fry, if you will.
And I agree with that. We have a lot still to discuss, and today we're just concentrating on the three most urgent groups that come to present themselves, and we will have a lot more to talk about in the months to come.
Dr. Bernstein.
Along the lines of pregnancy, if I understood, pregnancy loss was higher in vaccinees versus non-vaccinees, although not statistically significant, and there was limited data along those lines. Would there be value in objectively identifying that women are not pregnant before they receive this vaccine, given the limited data?
Yeah, so, in some of the trials, in the clinical trials, that pregnancy was an exclusion criteria, in the trials in the clinical trials that were done. So certainly, there would have to be some precautionary language on that issue.
Dr. Fry would like to offer additional comment.
Yeah, I think, again, we're just concentrating on these three major populations at hand here in the U.S., and there's not much data out there. And so there's a lot of low or uncertainty about recommendations or evidence to recommend. And so we want to be cautious. We're moving forward with these first three groups. We are going to vaccinate adults, people 18 years of age and older, who are relatively healthy and not pregnant at this time. Again, we hope to get more information as more and more vaccine is given, particularly in the trials that are ongoing. And we can, you can stop and think about this situation, I would say I would use a correlate as smallpox and talking about giving dry vax or ACAM, live attenuated viruses. And yes, indeed, if there was an outbreak of that, we would be vaccinating pregnant women and otherwise compromised hosts. But I don't know that we are at that point in this discussion, and those discussions definitely will be forthcoming.
Thank you. Ms. McNally.
Thank you. I'm specifically going to ask about the information that was contained in slide 28 on the BSL-4 personnel, who some anecdotally indicated that they were concerned about the potential desirable side effects of the vaccine, or just effects in general, not necessarily side effects. But do we have any additional information regarding what concerns they had?
So some of the concerns with the BSL population, and Sharon, do you actually want to comment on this first, or do you want me to? Okay, yeah. Some of the concerns with the BSL-4 population had to do with they feel, some of them felt, like I said in the slide, that there are other precautionary measures in place in BSL-4 laboratories, and as such, they didn't. Some of them didn't feel that vaccination would added that much to the protection that's already existed. Again, that was one of the things that we heard during our work discussions. At the same time, there are people within that population who have been vaccinated through PREPARE and are supportive of others being vaccinated. And then we also heard at the same time that there are groups within that population that wanted to take part in PREPARE, but because of their location and the travel, and then because it's a clinical trial, there's lots of follow-up that happens that has to be done at the clinical trial site, that they were not able to, take that time off. Some of it had to do with, sometimes it was a type of employee, whether they could take that time off and still be paid or not. So there were a lot of logistical and financial concerns that were impeding them from enrolling.
Dr. Fry, additional comment.
Yes, and I just remind everybody that the information that we have in these populations and their desire to receive vaccine or not receive vaccine is anecdotal. We did talk to some of the leaders in those supervisors or administrators in those areas. And again, what they were telling us was anecdotal. Some people, and everything Dr. Choi said is correct. Other things are like they wanted to wait to see more safety data when the vaccine was, after it had been tested further. And there were a variety of reasons that were given. The overall sense from the people that we did speak to was that the majority of those populations would be interested in having the vaccine available to them. Again, and of course, there's always a few people who would not, and I think pretty much covered all the reasons why they haven't already received it or were hesitating perhaps to think about taking it. And I think the biggest hesitation we're already doing a good job with our PPE, and let's get some more data before we decide to have a vaccination.
Dr. Cohn would like to offer.
Can you just clarify if there has ever been, what the risk is to BSL-4 laboratory workers in terms of, has there ever been a case of Ebola related to an exposure, or have there been exposures in this population?
So there has never been a case of EVD diagnosed in a BSL-4 worker in the United States. There was one that I know of in Russia, and that person, I believe, died.
Dr. Stinchfield, sorry.
Patsy Stinchfield from NAPNAP. I want to circle back to Dr. Lee's comment about the healthcare professional definition. And so this isn't an Ebola work group comment, but to the appropriate work group at ACIP. For healthcare professionals, hospitals and healthcare settings take that definition very literally. And as we saw today, it's not complete. And I think when we get into lists and policies and things like that, we find ourselves in trouble. For example, in our Children's Minnesota policy for proof of immunity to work at our hospital, we basically just put in the link to the CDC healthcare vaccination schedule. When you go there, there's a very abbreviated part of the definition that we saw today, and it does not include the sentence about including but not limited to. So it looks like the professionals that are listed on there are the professionals that is referring to, which I don't think is the intention. I would like to call people's attention to the NFID call to action on this topic, the improving healthcare personnel immunization rates. It was written in March 2018, and many of the liaisons here around the table participated in that, in improving healthcare personnel immunization rates, and basically came up with a much more simple definition, which is, I'll read it here, all healthcare personnel who work directly or indirectly with patients or who work in any capacity in a healthcare setting should be vaccinated in accordance with CDC recommendations. And then when you go to the CDC recommendations, there's the details such as for Ebola vaccine, if you're working in an Ebola treatment center, or for meninge, if you're a lab worker handling meninge isolates, et cetera. So I would really like us to go back and see if we can't work on improving that definition.
Thank you very much for those comments. Dr. Lee.
Thank you. I just had a clarifying question based on Ms. McNally's comment, which was when queried, were these actually frontline workers handling replication competent Ebola virus that were queried for acceptability, or was it generally sort of anecdotal reports from supervisors? I guess I'm more concerned about the frontline workers and specific to this recommendation category.
Introduce yourself. So I'm Inger Damon. I'm director of the Division of High Consequence Pathogens and Pathology. So that's where our BSL-4 laboratory work occurs here at the agency. And so in the history of the BSL-4 laboratory work at this institution, we've had no breaches in use of personal protective equipment and within the BSL-4, which has required the question of some sort of post-exposure prophylaxis or treatment. And so most other institutions that have BSL-4 labs track this very closely. To my knowledge, there is one example in Eastern Europe where there was an exposure where treatment with both one of the investigational antivirals and I believe also post-exposure vaccination was used. And I think Dr. Choi described the one episode in Russia where there has been an exposure. I think further, I think in terms of work in the field laboratory setting, in sort of CDC example, in terms of well-trained personnel and staff, ran and operated a laboratory which tested and processed tens of thousands of suspect Ebola samples and confirmed Ebola samples, had no known breaches and exposure, no infections. Some of our personnel had been vaccinated prior to going to work in that laboratory, and I don't know if Dr. Choi can remember the specific numbers of folks that we did have vaccinated through one or another of the investigational protocols.
Dr. Fry.
Dr. Daming, I'd like to ask you a question, sort of related, well, not sort of, it is related to policy in the Level 4 lab. Could you explain to us when it comes to vaccinating workers who are working in the Level 4 labs, if they're working with smallpox or anthrax or whatever it may be, if there is a vaccine available, is it the policy to recommend vaccination of the personnel prior to working in such a situation, or how does that work?
So it would be a decision to be made with occupational health, with a scientific program to understand the level of risk and the additional benefit versus risks that would be associated with any individual vaccine. So there is not a requirement for anthrax vaccination in our laboratories. There is a requirement for smallpox vaccination among our BSL-4 lab workers, and anthrax also is BSL-3, not BSL-4. And the smallpox decision was really made because there is no disease anywhere in the world. And so the potential risk for an undiagnosed exposure was what really led to that recommendation. In this instance, I think with the concern of, potential the additional barriers that we have to prevent infectious exposure within the BSL-4 laboratory, the training of our personnel, that this would really be then an individual decision that what should be made in concert with the scientific program and with occupational health to judge the level of risk. So certainly people handling animals and infected animals are likely at a higher potential risk than others, and really understanding people's level of risk in terms of the potential for an arthritis, which could be debilitating for a number of days and prevent ease of work. So getting around in a BSL-4 lab, you're carrying an additional sort of 5 to 10 pounds of additional weight in terms of the suit, breathing apparatus. And your mobility is a little bit less than what it's like to walk around in a normal environment. So.
I'm sorry, Ms. McNally.
I just wanted to follow up on these questions, and I am doing so because in slide 27, and as you stated, it indicates that there is no knowledge, attitudes, and practices surveys that have been conducted among these three populations. So in the anecdotal report that slide 28 refers to, do we know if the anecdotal reports indicated concern regarding the arthritis arthralgia or the potential vaccine-related events from pregnancy outcome? I want to just flush that out.
Sharon, I think you can help me with our recollections in terms of our work group discussions. As far as I recall, pregnancy was not an issue that came up. It was more perhaps related to the arthritis arthralgia and the reactogenicity that's associated with the vaccine. I don't recall a discussion specifically about concerns with pregnancy.
Okay.
I concur with that.
Thank you.
Are there any other questions or comments? Very good. Dr. Hunter.
So I think we have two fairly well-defined populations we've talked about so far, the BSL-4 laboratorians and people who go to a federally defined Ebola treatment center. But I think there's a third, the first group that we've talking about is a little less well-defined and could be volunteers in non-governmental organizations, people that are going over in various capacities that have various levels of risk. And I think that when we go back to, I think the first two questions that we asked Dr. Lee and Dr. Bernstein, if you combine those of, what level of risk is there, where are we on the ring, and just exactly how much of a risk there is for death, depending on whether you are out in the bush in West Africa and can't get medevaced because, things are breaking down as far as transportation, or are you in a regional center away from the outbreak and may or may not have direct contact with patients based on your assignment, or are you on your way and you may or may not have exposure depending on how long you're spending to go there. And I think that, there's going to be a lot of discussion about what is my risk and what are for dying and what is my risk for the arthralgia. I think that's going to be an interesting conversation. I guess I would assume that the simple policy statement that we say that it is recommended is going to need to have a lot of information for various levels of risk in the guidance that we're not going to vote on. I guess that's my bottom line, is that I would ask for that.
Yes, no, we absolutely agree. We did keep the definition a little bit broad. Initially, it was persons deploying to an outbreak, but we felt that on some level that limits it a little bit. As I mentioned, we did repatriate somebody during the current outbreak because of a high-risk exposure. And that is a U.S. personnel who is in DRC and works at a hospital in DRC. And he had contact because a pregnant Ebola patient came to his facility, and he took care of that patient. So that is why we kind of left out the word deployed, because there are organizations, oftentimes NGOs, that are already working in places where an Ebola outbreak hits. And so if we limit the language to deployed, it potentially puts them out of the box, when potentially they could be at risk depending on the transmission in the community.
Dr. Cohen, comment.
I just want to make an additional comment that while we're voting on the language that is in the recommendation in terms of these groups, there will be additional guidance in the policy note that's being written about sort of how to assess persons at risk and guidance for these organizations. This is really going to be a very risk-based assessment, not only for laboratory workers, but for all of these groups.
Dr. Bell.
Yeah, just to your point, which is a very good point, we've had a number of consultants on the working group from groups like MSF, some of whom in Europe are already vaccinating their responders and have developed some, clear and kind of targeted to the types of settings that their workers may come across. For vaccination, and we would anticipate, something similar, and would appear, as Amanda's saying in the policy note, because I think your point is very well taken. There's all kinds of different sorts of exposure, which, as I say, may be particular to particular organizations, and people are going to have to really work through that very carefully.
Dr. Fry.
So if we decide to recommend this vaccine, a ACIP recommendation does not make it mandatory for people to be vaccinated. It is definitely a recommendation, and I appreciate the fact that if people read, particular organizations read that ACIP recommends the person receives a vaccine, that automatically translates into you must be vaccinated. And that is not going to be, that is not the case, because we're talking about a general population. And we're talking about the risk of that population. We would give a lot, as Dr. Cohen has mentioned, a lot of guidance for how those decisions should be made. And it would be up to the organization to decide or determine what the risk is for their particular employees that they are administrating, and decide if they're at risk or not, and then offer the vaccine, not saying that it's mandatory, but it should consider offering it to them. And so there'll be a lot of guidance in that regard. And there's so many different individual situations that can come up, so it really needs to be a discussion that needs to occur at the level of employment, if you will.
Dr. Cohen, comment.
I just want to add to that, not only will there be guidance about who should be considered for vaccination, but also groups that should not be. And so language around the healthy definition and things like that. I do want to ask, has there been any discussion about an upper age limit at all in terms of a recommendation? Or would there be information about sort of use of this vaccine in older adults?
No, when we looked at the clinical trials, some of them did have an upper age restriction. I believe it was 65, but in our discussions, we had not talked specifically about setting an upper limit.
Dr. Fry.
And that gets back again to the definition of what is healthy. And as we all know, the older you get, the more situations you find yourself in as far as morbidity or comorbidities.
Are there any other comments or questions? Yes, please.
Sandra Fryho for American Medical Association. As a practicing physician and as a member of this working group, I have to just tell you how much I appreciate all the questions that came from ACIP regarding this decision. And I also have to say what a fabulous job our two CDC leads have done in looking at this. I don't think they've slept over the last few months. So thank you so much for your hard work.
Thank you for those comments. Any other questions or comments? Very good. Then we're going to take a 30-minute break at this time. Let's come back at 5 to 11. And then we'll propose the language for the proposed text for the policy options. Thank you very much.